Thank you. Cutler?
Thanks. Well, as John and Mark have indicated, there's a lot of intimate connection between energy, water, and climate change, and also with ecosystems, as Bill will talk about. The food production system is unique in terms of energy in that it's both a producer and user of energy. The industrial agriculture and the whole food system consumes enormous amounts of fossil fuels and electricity, but it also is now being increasingly called upon to produce energy, largely in the form of biofuels, ethanol and diesel. This duality creates an interesting connection between the food system, which we tend to think of as in this silo, and the energy sector, which we tend to think of over in this silo, both in academia and in federal governments. But there's a lot of connections between those silos now that have to be addressed. It also means that decisions made in agricultural policy have impacts on energy, the availability of transportation fuels, and decisions in the energy policy sector, such as the mandate for certain amounts of biofuels, also has implications for the agricultural sector. And environmental and climate policy affects everything. Industrial agriculture, as you all know, is a very energy-intensive operation. Anywhere between 5 and 10 calories of fossil fuel is used to grow 1 calorie of food energy in the United States. Just think about that. I mean, that's a startling statistic. If we were a hunter-gatherer society, of course, that type of food production system wouldn't be sustainable, since you have to produce more energy than you use if you're an organism. But we use fossil energy to produce food calorie energy, which are different qualities. So we can afford that luxury. But it's a heavily dependent system. And therefore, farmers and rural communities, the communities that farmers live in, are very sensitive to changes in the price of energy. In the United States, about 5% of farm expenses are related to direct fuel purchases. Another 9 to 10% are related to the indirect purchase of energy embodied in chemicals, fertilizers, pesticides, and the whole suite of inputs that goes along with industrial agriculture. Farmers have responded to those changes in energy prices over the last 20 years and have become more energy efficient in terms of the use of water, their tillage, fertilizer applications, so on, but energy prices remain very important. If you look at the rest of the food system, downstream from farmers, food processing, preparation, so on, if you add all that energy up, it's probably about 15% of all the energy used in the economy. Although I have to say that no one's really studied this issue since the early 1980s. So we really don't know, have current information about what the total demand on the food production system is for energy. We haven't talked a lot about the oceans, but I want to briefly mention the fact that we get a lot of protein from fish, and that has enormous energy implications as well. We've basically decimated most of the capture fisheries on the planet, offshore commercial fisheries, which has dramatically increased the cost of harvesting fish. In New Bedford, from my neck of the woods, New Bedford, Massachusetts, back in the early 1980s, the fleet out of New Bedford, which fishes on the Georges Bank in New England, used six calories of diesel fuel to get 1 calorie of fish protein. Now they use 40 calories of diesel fuel to get 1 calorie of fish because they have to steam further, trawl deeper, and so on. The shift from capture fisheries to aquaculture, 20% of the fish protein in the world now comes from aquaculture, has important energy implications as well because aquaculture is intimately connected to the agricultural system as well in terms of their inputs. In terms of the demand for biofuels, so now we're calling on agriculture to produce more energy due to historic subsidies for ethanol and other fuels, mandates, which were talked about earlier, for more biofuels, high oil prices, so we think we need something other than oil to run our transportation system on, climate change, the need for lower carbon fuels, biofuels are touted to be lower carbon. So all these suite of forces is driving the demand for biofuels. Ethanol production from corn in the U.S. doubled in the last 3 years. 30% of the corn acres planted last year now went to corn for ethanol. And so this has a whole suite of new issues that we're just I think, just now realizing that we have to grapple with. The impact on commodity prices is a hotly debated one. There's no consensus at all by people who study the global food market, and it is a global market, on what impact corn for ethanol has on global food prices. Some see it as the root of all evil. Others see it as a small player in a whole suite of international macroeconomic forces. The rise of ethanol raises the food versus fuel debate. My God, how can we grow food to put in gas tanks of SUVs on California freeways when people are starving to death in the world? And that range of debate runs the full gamut as well. Contrarians say, well, most of the corn that would be grown for ethanol would be fed to livestock and not people. Increased crop yields will alleviate the need to cultivate more land elsewhere on the planet. So there's a rich debate on the food versus fuel issue. The carbon issue is another really interesting one. If you look at most historic, what are called wells to wheels analysis of this carbon dioxide, the greenhouse gas emitted from conventional motor gasoline, from oil, through refinery to your gas tank, as opposed to corn, biorefinery, ethanol, most wells to wheels analysis suggests that corn from ethanol in the U.S. gets you a 20% reduction net in CO2 emissions relative to conventional gasoline. But in the last couple of years, that's been called into question by a lot of terrestrial ecologists who say, now wait a minute though, if you're converting land, if you take land out of production for food to grow ethanol, somewhere else in the world, land might be brought into cultivation to produce that. What if that's deforested land in Brazil? So you cut the forest, burn the forest, the carbon goes up in the atmosphere. So the net impact on the carbon cycle, according to some analyses, you may actually be worse off with ethanol, depending upon how this plays off. So that the impact of ethanol on the carbon cycle is a really critical one.
30 seconds.
Thank you. In my paper, I had a whole suite of data and indicators. What's interesting to me as an energy analyst is how disconnected the information about energy and agriculture is from information we traditionally think of as energy. If you go to the Department of Energy website, who collects data on energy use, and you want to find information about ethanol, you have to go to the Petroleum Supply Annual, because they think of ethanol as transportation fuel. You stick it in the gas tank, so that's kind of like oil, so we're going to stick that data over here. If you go to the USDA sites to get information on ethanol, that's over in the grain stuff. Well, it comes from grains, that's farm, so we'll stick it here. And so if you want to really get a systematic view of ethanol as it comes grain from the farm through the system to the consumer, it's very hard to find good information. So one recommendation is to get the USDA and the Energy Information Administration folks talking to each other to come up with some sane database so we actually know what the connection is between food production in the U.S. and energy use. And I would say the same thing goes on the policy side, where we have policies being promulgated to do energy stuff, but really ripple through to the ag sector. We have ag policies promulgated to do something for farms, but those ripple through to the energy sector. And we need much more understanding and cohesion between the connection between those policies.